I'm Ian O'Neill, the space producer for Discovery News. These videos that you're seeing from the SDO, which is the Solar Dynamics Observatory, are actually coming from the first observations of this mission. The surface of the Sun is very, very turbulent, very dynamic, and so you always get these events where you get a release of energy. It's like a valve being released in the magnetism on the surface of the Sun, which opens up like this hose pipe of plasma. And in this video, you can see relatively cool coronal plasma, and that's the plasma that you find coming from the surface of the Sun being pushed into the atmosphere. And what you're seeing is this forest of magnetic field lines protruding from the surface of the Sun and ejecting plasma into space. And in the first video, you'll see that this plasma is shot up into the atmosphere, and when it starts to fall back to the surface, that's called coronal rain. And the biggest question surrounding this coronal rain is, why isn't it falling to the surface faster? Because the Sun has a massive gravity, so it should be pulling this plasma to the surface very, very quickly. And that's why we go on to the second video. You're actually looking at the multicolored plasma. I mean, it's not actually this color, that's false color that's been overlaid, so you can tell the difference between different temperatures of plasma. And the hotter plasma you can see are like the blue hues, and the cooler plasma is the reddish hues. So it's a lot hotter than the first video. But as the coronal rain is ejected from the surface of the Sun, scientists are now beginning to see that it's the pressure or the cushioning effect of this hotter plasma underneath the coronal rain, which is actually slowing down its motion towards the surface. So this is really important research, because for the first time we're getting such a high definition look near the surface of the Sun, and hopefully will feed into extended research as to why the solar atmosphere is so hot.